96%. That's how often Lemonade's claims bot takes a claim straight from a customer, no human in the loop at all. And 55% of the time, it just closes it, end to end, while you're still holding your phone. I read that in their 10K and thought, okay, that's genuinely impressive. So how does it work? And that's the thing. They'll tell you what it achieves in detail. How it decides, almost nothing. Hi, I'm Tanmay Kulkarni. This week I wrote a case study on Lemonade's claims automation, then built a working reference implementation of the workflow behind it, so I could see where the hard parts actually lie. 3 stages: intake, verification, authorization gate. A claim moves through them in order, and it stops the moment one of them says no. Before we open any of it up, here's what I'm going to ask at every single stage. 4 questions. What's mocked? What did I make up, and does the code admit it? What happens when it says no? And could you prove afterwards what happened and why? That's the whole method. Watch me run it 3 times, then run it on your own thing. Let's make that concrete. The case study walks through an illustrative scenario. A customer we'll call Sophia. She isn't a real Lemonade customer. She's a worked example, deliberately built to stay inside what Lemonade has actually confirmed. So Sophia files a claim. Her dog had a vet visit for kennel cough. $120 1st of May. That's free text. Intake's whole job is turning it into something checkable: diagnosis, amount, date, and a confidence score. 0.95 here, comfortably above threshold, so it moves on. Here's what's actually holding that up. In my scaffold, Intake talks to a fake adapter, deterministic, free, returns perfect JSON every single time. A real model won't. It'll wrap the JSON in an explanation, invent a field, or just time out. So you need retries with backoff, schema validation on every response, and a fallback for when it fails anyway. And it stops being free. Every claim is now a token bill, and a latency budget you're answerable for. Stage 2. Verification runs 4 checks in order and bails at the first one that fails. Are the diagnosis, amount, and date all actually there? Does a policy record exist for this customer? Is there a fraud signal on them? And does what they claimed match what the record says with intolerance? Sophia clears all 4. And notice every rejection gets a named reason. Not needs review. No record found, mismatch, fraud flag. You always know why a claim stopped. Both of those data sources are mocks. A fake database, a fake fraud signal. Swapping in the real ones is the easy part, as long as the interface stays identical. That's the whole reason they're separate files. The part I'd flag: keep fraud genuinely independent. Don't fold it into the record lookup as one more field. Lemonade's fraud system and its claims bot are 2 different things, and outside coverage keeps merging them into one. I didn't want my own code repeating that mistake. And that matching tolerance, I made it up. It's labeled, but it still needs tuning against real claims. Quick one before we go on. 2 undisclosed values so far, and I invented a number for both and labeled both. There's a 3rd. So, what did I put in the authorization gate? Commit to an answer. Stage 3. And this is the one I keep thinking about. Lemonade's own 10K says AI Jim triages claims he's not authorized to settle to a human expert. So the authority has a boundary, they say so themselves. But nowhere in any filing, shareholder letter, deck, or interview do they say where that boundary actually is. No dollar amount, no claim type, no confidence score. So here's my authorization gate. That's the whole file. There's no rule in it at all. It calls a policy function that you have to supply. I could have put a number in there, but settlement authority might not even be a dollar amount. Writing under 500 would quietly claim that it is, and I don't know that. The absence is the honest answer. Which raises an obvious problem. If the gate has no rule, how does the demo run at all? It supplies one, amount under 500. And here's the bit I want you to notice. That number is invented exactly like the other 2, but it deliberately carries no DEV marker. Because a DEV marker is a promise, it says this is a real default, go tune it. This isn't that. It's a test prop. Labeling it would have been its own kind of lie, just a quieter one. Which makes this the stage that production changes most. Because in a real insurer, that policy function isn't code somebody writes on a Tuesday. It's a decision a compliance team signs off on. So you'd need an audit trail, every claim, the inputs, the outcome, and which version of the policy decided it. You'd need to explain a denial to a regulator in plain English. You'd need idempotency, so a retry never pays the same claim twice. None of that is in my scaffold. All of it is non-negotiable in production. 43 tests, all green, and here's what that buys you. The wiring is proven. Some of these use spies to show a rejected claim never even reaches the next stage, not that it returned the right answer, that the later code never ran. So you don't have to build any of that. Clone it, add your API key, and you're straight into the interesting part, watching a real model hit these stages and finding where your own claim data breaks it. That's the one thing tests can't tell you. Everything else is done. So your turn. Take something you've built that talks to a model, a demo, a prototype, anything, and run those same 4 questions on it. What's mocked? What you invented and whether the code says so. What happens when it refuses, and whether you could prove afterwards what it did. Write the answers down, then pick the single one that'd break first with real users on it. That's not a to-do list, it's your honest distance from production, and you'll be closer than you think on most of it. You'll just know exactly where you're not. The case study and the full implementation are both linked below. Thanks for watching. I'm Tanmay Kulkarni.